Hello, this is Sadbir. The topic of our discussion in this video is limit at infinity. In the first part of the video, we will discuss when the infinity is in the output of the limit. For example, here, when I approach limit as x, when I approach x from the zero, from the negative side or from the left side of the function 1 over x, I can see my function value or the y value of my function is going to a very large negative number. So I will say that the output of my function as I go closer and closer to 0 is a negative infinity. And also the limit as x approaches to 0 from the right, my function 1 over x is getting really larger and larger, a larger positive number. So therefore it's a positive infinity. So as you can see, this is going to a positive infinity. So two-sided limit as x approaches to 0 of this function 1 over x is dne, because the left limit is not equal to the right limit. In contrast to that, this function, if you approach the 0 from the left of 1 over x square, as you can see, the output is getting larger, so it's going to the positive infinity. Also, when you approach 0 from the positive side, your output 1 over x square is getting again a large positive number because you have a square in the denominator. So in that situation, the limit x approaches to 0 or 1 over x square is positive infinity. And as we can see that no matter in which direction we from the left or from the right, when we approach the 0, the output of the function or the height of the function is getting larger and larger, and they are approaching to a very large number, which is we call plus infinity. So this is a way to calculate the output in the infinity by looking at the graph of the function, how to calculate algebraically. So here I have a function, the limit, I'm going to compute x approaches to 3 from the positive side of this function to x plus 2. We can observe as x is approaching to 3 from the positive side, the denominator term 2x plus 2, it is approaching to number 8. 6 plus 2 is 8. However, when I approaching to 3 from the positive side, the denominator term 3 minus x, this number is getting closer to 0 from the positive side. This is approaching to 0 but from the positive side. So if I divide these two numbers, I would have 8 over 0, the number very close to 0. So a number, when the denominator is really small, that number is really large. So as I can see, this will be a really large positive number. So that limit will be a positive infinity in the output. Similarly, if I approach x approaches to 3 from the negative side, 2x plus 2 divided by x minus 3, as you can see, the top will approach to 8, but the bottom will approach to 0 from the negative sign. It will be a very small negative number, and number over a small negative number is going to be a really small negative number. So this will be a limit minus infinity. So if you have a number over 0, this limit exists. Now it will be a plus infinity or it will be minus infinity, depending on the what is the sign when you plug a number really close to 3 from the left or 3 from the right. So the sign will depends on the sign of that quotient, because in that situation our top is always positive but the bottom was the negative. So this is a way to calculate the limit involving infinity in the output for a rational function. Here I have one quiz problem for you to practice. Pause the video for 1 and 2 minutes Once you have your answer, you can leave the answer in the link above. The limit at infinity has one application to calculate the vertical asymptote. So if you have infinity, whether you are approaching the limit x approaches to a from the left or right, if you get the infinity plus or minus infinity in the output, that will implies that this limit where you are approaching your input, this input x is equal to a will call the vertical asymptote. For example, in the previous example, limit x approaches to 3 from the positive side of 2x plus 2 and x minus 3, it was a positive infinity. So this is enough to show that x is equal to 3 is a vertical asymptote. Our second topic of this video is when the infinity is in the input, when you are approaching your input to the infinity and you want to see where the output is approaching to. For example, in this case, I can see that when my input, this is my input line, when I'm approaching to infinity, the output, the y value of the function is approaching to 0. So I will say that the limit as x approaches to infinity, if a positive infinity, 1 over x is 0. The y value is approaching to 0. Or in other word, 1 over very large number is very small, and very small number is 0. The same thing is if I approach x approaches to negative infinity, I have 1 over x. As I can see in the graph, it is also the y value of the function is also approaching to 0. Or in other word, 1 over very small number, very large negative number is also very small. So 1 over large, number over large is small. And here you can see that if x approaches to plus infinity of 1 over x square, that will be 0. The limit x approaches to minus infinity, 1 over x square is will be 0. Because 0 does not have any sign, so it will not be positive or negative. If it's 1 over very large negative number or 1 over very large positive number, both will give you a very small number, which is really close to 0. So here I have one conclusion that no matter what you have, when you have 1 over x to the power something, it is always 0, provided that when you are approaching to a negative number, you have to be careful with this power. Like if I approaching x to negative infinity, 1 over x to the power 1/2 is not defined. As long as your exponent, the denominator of your exponent is not even, you will get 0. But if it is a even and you are approaching to x approaching to negative infinity, that number is not defined because the square root of a negative number is a complex number, which is not a real number, which is not defined in this class. The first things I will do is I will pull out the highest degree term from the top and bottom. So I can see highest degree term in the top is x cube, and if I pull out x cube here, I will left 2, and here you can see there is a no x cube, there is only x square. So what I will do in order to make a x cube, I will multiply x in the top and x in the bottom, so that become x cube. So I will pull that out, so this will become 3 over x, so x in the bottom will left. So you can see here is the x square. In order to pull x cube, you have to pay 1x here. So you have to take a loan. Same thing is here. If I want a x cube, I will multiply x cube in the top and x cube in the bottom. And I will pull out what is in the top. So 10 over x cube left here. And same thing I will do. I will pull out x to the power 3 from the top, highest degree term, which will be a 4. 3 over x, because there is no x cube here, and 22 over x cube, because there is no x here, so I have to take x to the power 3 as alone. In the next step, I will cancel out x to the power 3, and I have limit as x approaches to infinity, 2 plus 3 over x plus 10 over x cube, 4 plus 3 over x, 22 over x cube. And from 1 over x to the power n is 0, depend where you're approaching from plus infinity or minus infinity. So it means this term, number over very large number, is 0, and same thing, this is 0, so this is 0 and 0. When x is in the denominator and you are approaching x to infinity, all these terms vanish. So this is a 2 plus 0 plus 0 divided by 4 plus 0 plus 0. So your final answer is 2 over 4, which is a 1/2. So to calculate the limit of the rational function, so always you have to basically pull the highest degree term from the top and bottom. If you have a polynomial in the top and polynomial in the bottom, so there will be three situations will happen almost all the times when you're computing the limit. If the degree of the top is smaller than the degree of the bottom, it means the degree of the bottom is a larger. It means this number will grow faster. So number over a very fast number is going to be a large number is going to be a 0. So your limit will be 0. And this is the example. Suppose limit x approaches to infinity, 2x plus 1 over x square plus 1. So this is the limit is going to be a 0, because the degree in the bottom is larger than the degree in the top. Here another example which we just did in a few minutes ago. If the degree of the top and bottom is the same, then the limit is basically the coefficient of the highest degree term. So it's a 2 over 4, which is a 1/2. And if the degree of the bottom is smaller than the degree of the top, suppose the limit x approaches to infinity, x square plus 1 over 2x plus 1. So this limit will be plus or minus infinity depending on this, as I'm getting x is a larger, depending on where this the top or bottom they are taking a negative number or positive number. But when the degree in the top is larger, because top is larger number than the bottom, so the limit is either plus or minus infinity depending on the sign of the largest term on the top. So if I have a negative here, then I will get the negative in the infinity. So it's going to be depend on the sign of the largest term. If I have positive here, I get a positive here. Here I have one more example. When you have the square root of function in the top, in this examples, we will calculate the limit by pulling out the highest degree term inside the square root, and then we will simplify. So the first things we will do is we will basically pull out x to the power 6 inside the square root, and this will give you 3 over x to the power 6, because in order to pull out x to the power 6, I have multiply and divide by x to the power 6 on the top and bottom. And then since I pull out 6, this will be, and if I pull highest degree term x cube from the bottom, it will be 1 over x cube minus 2, and this is the limit x approaches to positive infinity. Now we will use this property, the square root of a times b is equal to the square root of a times square root of b. Therefore, this will be limit x approaches to plus infinity, the square root of x to the power 6 times the square root of 3 over x the power 6 plus 9, and this is a divided by x to the power 3 and 1 over x cube minus 2. Okay, here we will simplify what is x to the power 6. x to the power 6 is x to the power 1 half, which will be x to the power 3 if x is a positive, and it will be minus x to the power 3 if x is negative, because this is sort of the absolute value of x to the power 3. It's the same thing as the absolute value of x to the power 3. So since my x is a positive, I'm approaching to the positive infinity. It means this is a limit x approaches to positive infinity. That will be x cube positive divided by x cube, and this is the square root of 3 over x to the power 6 plus 9, and divided by 1 over x cube minus 2. This will cancel out, and if I plug x to the power infinity, this is a term go to 0, 3 over x square and 1 over x square. So I will get square root of 9 divided by negative 2. So my answer will be minus 3 half. To also notice, if I compute the same limit as x approaches to minus infinity of this, so here x to the power 6 will simplify to minus x cube divided by x cube, and the square root of 3x to the power 6 plus 9 divided by 1 over x cube minus 2. So in this case, I will cancel out this. I will get negative square root of 9 divided by negative 2. The answer will be 3 half. So it will be really matter when you simplify x to the power 6. If your x is going to a positive infinity, you will choose x cube. But if x is a negative infinity, you will choose minus x cube. Here I have one more example for us to practice. So here first we will see that what is the largest degree in the top. So as I can see, 4/3 is the largest degree in the top. So I will pull out 4/3, and I will get a 1 minus. So in order to make a 4/3, I need to multiply t on the top and t on the bottom. So 1/3 plus 1 is 1/4. So I will get 9 over t in the bottom. And same thing is, if I pull out x to the power 4 inside of this parentheses, I will get 8 plus 2 over t to the power 4 and to the power 1/3. So since the power can distribute, so I will have limit as t approaches to infinity, t to the power 4/3 and 1 minus 9 over t divided by t to the power 4/3 and 8 plus 2 t to the power 4 to the power 1/3. This 1/4 cancel out. If I plug t approaches to infinity, this term will be 0, this term will be 0. So I will have 1 over 8 to the power 1/3, which is 2 times 2 is 1/2. So this is the limit as t approaches to infinity of this example. Here I have one more question for you to practice. Pause the video for 1 and 2 minutes, and once you have your answer, leave your answer in the link above. So here I have one challenging problem where we calculate the horizontal asymptote of this function. So you know the definition of the horizontal asymptote is basically y is equal to the limit as x approaches to plus infinity of the function, and also y is equal to x approaches to negative infinity of the function. First, let's calculate the asymptote when x approaches to plus infinity. So this will be the limit as x approaches to plus infinity of this function, 4x square plus x minus 2x. As I can see, the degree of this term and degree of this term both are almost same. So if I plug infinity directly, I have an infinity minus infinity, and I would not know which term is growing faster. So in order to calculate the limit, I have to simplify this this function which has a square root, and I will do it by multiplying its conjugate. The conjugate of this function is when you change the negative sign to a positive sign, and I will divide, multiply and divide by its conjugate. If I simplify the top, I will get 4x square plus x minus 4x square. And if I I don't need to simplify the bottom, but say x square plus x plus 2x. So this goes to 0, this cancel out. So I have a limit as x approaches to minus infinity, plus infinity is x divided by 4x square plus x plus 2x. So now limit x approaches to infinity, x over, I will pull out x square from this square inside the square root. So if I x square, this will become the square root of x and the square root of 4 plus 1 over x, and then this is a 2x. So we know that the square root of x square is plus x or minus x if x is a positive, if x is a negative. So since my x is a positive, so this will give me limit x approaches to infinity is going to be x divided by x square root of 4 plus 1 over x plus 2x. Now I can pull out the x and cancel out in the top. So I will get limit x approaches to plus infinity 1 over square root of 4 plus 1 over x plus 2. If I take x to infinity, this will be a 0. So I will get 1 over 2 plus 2 is equal to 1 over 4. So this implies y is equal to 1 over 4 is one asymptote of this function. To calculate the other asymptote, if it is exist, you have to calculate the limit as x approaches to negative infinity also. And if you get a number, then that is a asymptote. If you don't get a number, you get an infinity or plus minus infinity, then that number uh, is not an asymptote. Hello, this is the end of this video. Thanks for watching. Bye for now.